Hello, everybody, and thank you for joining us today for Vertica Unify 2021. This breakout session is entitled XGBoost in Vertica for Classification and Regression. I'm Joy King, and I lead Vertica Product and Go-to-Market Strategy. I'll be your host for this breakout session. Joining me is Wakas Dillon, Vertica Product Manager for Machine Learning and Advanced Analytics, and George Larionov, Vertica's ML Software Engineer. But before we begin, I encourage you to submit questions during the virtual session because you don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to the end to gain points so you can participate in our Analyze to Win competition and win prizes. Now, let's get started. Over to you, Wakas and George.
Thank you, Joy. Hi, everyone. So today we're presenting XGBoost in Vertica. This is a new algorithm that we have recently added to our machine learning library. But before we dive into the algorithm itself and the implementation, let's just quickly do a quick overview of what's there in the machine learning library in Vertica. So as many of you might already know, there are multiple ways of doing machine learning in Vertica. It's a pretty vast library with hundreds of functions starting from very basic means and averages and standard deviations to more complex algorithms, including the one that we'd be talking more about today. So in terms of approaching the machine learning library, there's multiple ways of doing that. You have the normal SQL API, the SQL front end, with which you can write SQL queries. So just like you'd write queries for joins and other database operations, you can write similar queries for doing analytics and machine learning. Then another way of doing machine learning with Vertica is through the Vertica Pi library. Now, this is a Python interface with SQL in the backend. So if you want to think of it in terms of a client-server application, this would be a client application which would send queries to Vertica server. And then your queries are parallelized across all the data in Vertica. So Vertica takes care of all the parallelization, converting that into the right format and making sure that the queries are optimized as well. So you get the best of both worlds. You get a nice interface from Python and you get a good backend from Vertica. If you guys are actually more interested in more about Vertica Pi, there's a separate session by Badr. I would strongly suggest that you guys attend that. There's a ton of cool functionality that you'd want to know there. The third method of doing machine learning Vertica is through user-defined functions. You can write those in C++, Java, Python, and R. And it essentially allows you to write your custom functions and bring them to Vertica for hosting, for storage, as well as for running them. Two of, I would say, the more recent functionalities that we have added are TensorFlow import, whereby you can write your model on any configuration you want, whether GPUs, CPUs, or whether on-prem or on cloud, whichever suits you. But the only thing you have to do is when you write these models, you have to store them in TensorFlow's native graph format, and then you can bring those models into Vertica for archiving and prediction. Now, important thing to know here is that these models need not be already supported by Vertica. So any model that you can think of that you can build in TensorFlow, you can essentially bring that to Vertica. So it would also include neural network models or any other unsupervised machine learning models that you might want to bring there. And the final method is PMML. It's sort of a standard format for bringing models between different tools, exchanging them between different tools. So what you can do is you can build a machine learning model or hundreds of them in any tool of your choice. It can be Python, Spark, or any other tool that supports PMML. And then you can bring those models into Vertica for archiving and prediction. Similarly, you can build a model on really large data sets in Vertica and take it out for prediction, for example, on an edge node, where it would help you with the accuracy that you got from training over all your data, but also with the speed that you would get closer to an edge node. And these two methods of PMML and TensorFlow, essentially when you bring a model to Vertica for all practical purposes, it is treated just like any in-DB Vertica model, whether you have created it through the SQL interface or the Python Vertica Pi interface, meaning that all operations that you can do on a model, like renaming a model or setting the security rights on a certain model, or dropping a model, you can perform all of those operations on these models that you've brought to Vertica. So what is the capability like when we think about machine learning in Vertica? There's actually a whole lot of functionality here, as I mentioned, starting from basic functions like data analysis and exploration to more advanced functions in data preparation, model training, and prediction. There's a lot of algorithms for that, including XGBoost, as mentioned on the top here. And then there are functions for model evaluation and finally deployment. So the important part is that all of this pipeline, you can do it in Vertica. But the way it has been designed is that it doesn't restrict you to doing that only in Vertica. What that means is, let's say you find Vertica as a really good choice for some of the data preparation functions that it has. You want to clean your data, or you want to run the PCA algorithm that Vertica has to do feature engineering. So you can do that, and then if you want to extract that data out to, let's say, TensorFlow or some other tool for model building, you can do that, and then bring those models again back to Vertica for prediction. So these are all the choices in which Vertica frees you up in terms of your implementation. So if you want to do it end to end, all in Vertica, you have all the right tools here. If for any reason you want to do one of these steps or multiple of these steps outside of the database, you can do that too. So it's really freeing you from all those restrictions that you might face in other tools. And again, any of the functions that you see here, they are built to perform really, really well on really large data sets. So if you are restricted by the amount of data that your current tools can handle, it would take care of that. It comes with built-in security and all the performance that you'd expect from a data warehouse like Vertica. So moving on, a quick intro to XGBoost. What is XGBoost? It's a popular tree-based algorithm for classification and regression. Kaggle is a pretty popular data science website which hosts competitions from time to time, and it has come out as the top algorithm in the past few years continuously. The only algorithm here we see, or the class of algorithm we see here in the graph, which is the red line, are neural networks. But leaving neural networks aside, which have their pluses, but can also suffer from the problem of not being open. You cannot go into a neural network and clearly identify why a prediction was made in a certain way. So leaving that out, XGBoost is probably your best choice right now in terms of these competitions if we see the results. So based on those results, we've seen similar performances at our customer sites in their data. The only problem they face is that the algorithm itself is not very scalable in a lot of tools. Many of the tools are compute engines which are just single node, so they cannot handle any large data set anyway. But some of them, which are even distributed, are bound by the amount of memory that's available to those systems. And as you guys might already know, Vertica doesn't have any memory limitations as such that any operation that it needs to perform, and it requires more space than is available in the memory, we do an automatic spill to disk. So you'll still get your results instead of getting an annoying out-of-memory error. So that's one of the really cool things. Again, one other characteristic that is shared by XGBoost with other algorithms in Vertica is the fact that you can run it on all of your data. So it is doing that distributed and parallelized training, as we'll see in a little bit. I've gone through some of the benefits essentially, but just quickly summarizing them again. Why would you want to do XGBoost in Vertica as compared to any other tool? The first and the foremost reason for many of our customers is the speed that you get by running XGBoost both for training and prediction in Vertica. The second part is around scalability. You can train and deploy these models at massive scale. Essentially on all the data which can fit in Vertica, you can train a model on that, and you can also make predictions with that. And the final part is around explainability. As I mentioned, neural networks can be black box methods, and they are highly effective. But if, let's say, you have a use case, and in one of our customers, which is a bank that needs to make decisions on whether to give a credit card to some users or not, there are sometimes requirements where you are asked a question by either regulatory or compliance, or some internal function, that why a certain application of a certain user was denied for credit card, whereas the same application from their spouse or somebody they know with similar traits was accepted. So that explainability is something you can go in Vertica. It's a storage layer along with the compute. So all the models that you build over time, you can keep them stored in the data warehouse. You can go and look at what the exact model was at a certain point in time, which was responsible for making a certain decision. And you can exactly look at the parameters that were responsible for making that decision. So that model explainability, that's really high, along with the fact that you can keep on storing these models. So that model governance and pipelining also becomes pretty easy, and you can pull out those models at any point in time. So with that, I'll hand it over to George, who will take us into more in-depth explanation of the algorithm, its implementation in Vertica, and explain it to you with an example. Over to you, George.
Thank you, Waqas. Yeah, so as Waqas mentioned, I'm going to be talking about XGBoost a little more in depth. And so first I'm going to talk about overall, how the algorithm works and what it does under the hood, and then I'll take you through some examples. So XGBoost is basically an algorithm that trains a set of decision trees on some data set provided by you in order to perform either regression or classification on either the same data set or a new data set of the same format. So we'll talk about exactly what decision trees are in the next slide, but first I just wanted to take you through the main idea. So kind of the theme of XGBoost is that it trains these decision trees, which are pretty weak algorithms all by themselves, but they are very fast and pretty easy to train. And so XGBoost stacks these on top of each other, with each subsequent tree filling in the mistakes of the previous trees. And at the end of the day, it's left with a very powerful model that's made up of a bunch of smaller models. Yeah, and so it's a little explanation of decision trees. So poison ivy is, as the name suggests, it's a poisonous plant that exists in, I think, all of North America. So maybe if you're from Europe, you might never have heard of it. But basically, if you're outside and you touch some poison ivy, you get this horrible rash on your skin, and then it spreads, to other areas. So basically, it's just something that you want to avoid at all costs. And so here on the right, we have a decision tree, which just classifies whether something is poison ivy or not by its traits. And you might know this as a flowchart, but a flowchart is a type of decision tree. So in this case, we have three conditions. Are the leaves in sets of three? Do they have jagged edges? And do they have pointy tips? And so if any of these are not the case, then it's not poison ivy. But if all of them are, then it is poison ivy. And so this is obviously a very simple decision tree. They get much bigger. And another key point is that they don't have to be just these splits. Each of these conditions is called a split. These splits in this case are just yes or no, but they can also be based on values. So instead of, in a different problem, it might be, instead of are the leaves in sets of three, it might be, are there greater than 3 leaves? And that splits some data points to go either left or right. But yeah, this is the general idea. And the other key difference that sometimes might happen depending on your problem is, in this case, this is a classification problem because we're classifying plants into either poison ivy or not poison ivy, two classes. But there's also regression problems. So if we're predicting price or cost or some numeric value, that would be regression. And so these ends of the flowchart, not poison ivy and poison ivy in this case, can also be values. Yeah, so first I'm going to give a little toy example. And for this example, I chose a data set of car prices. So the data is a bunch of cars, and the columns are make of the car, year of the car, and its price. And the problem to predict on is given the make and the year of a car, predict the price. And so this is going to be a pretty simple toy example, but the idea is applicable to any column or data set with a single output column, which is basically just the requirements for any regression or classification model, not just XGBoost. Yeah, so here's the data set. It's just 10 cars. As you can see, there's a variety of years. There's only, the makes are only Toyota and Lexus. And there's different prices. And so if I was asked, as a human to somehow build some sort of model to classify new incoming cars, one of the first things I would do would probably be to sort this data set by make, which I've done here. And so in fact, this is actually likely the first step that XGBoost would do if given this simple data set. And so it would predict the price for a decision tree of depth 1. It would predict the price just based on the make of the car. Now, this isn't obviously a very strong model because it just takes the average of all the Toyotas and the average of all the Lexuses. But it does offer a somewhat decent result. And more importantly, for our case for now, is that it's simple and that it's very, very fast. So, the next step after this might be to add another layer to this tree. So this is a decision tree of depth 2. And in this case, after splitting on the make, we then also split on the year. And so for Toyota, the algorithm decided that the best place to split would be 2011. And as you can see, the cars older than 2011 are predicted to be $6,000, and newer will be about 21,000. And for Lexus, there's a different split. And so this is still, a simple model. It's still very fast. As you can see, it wouldn't take much to store this model and give predictions because you need to store like 6 things or something like that. But now we give a half decent estimate. And so the XGBoost breakthrough, if you will, is what if we take a bunch of these decision trees, usually deeper, much deeper than depth 2, but not by too much, maybe 5 or 6. What if we take a bunch of these decision trees, which by themselves are not very strong models, and train them subsequently, one after the other, and allow the later trees to kind of fill in or correct the mistakes that the previous trees made instead of all being completely separate, as in random forest. Yeah, so here's just a pretty simple example. Again, even with 2 decision trees, the predictions made on that 10 car data set are never going to be very good because there's just not a lot of data, but the algorithm did its best. And so in this case, you can see, so we already saw the left tree, but the right tree, instead of independently predicting prices, it adds on to the, or subtracts in this case, to the predictions of the previous tree. And another key point is that the tree on the right splits on different values. So it splits on 2015 instead of 2011 or 2016. And you can imagine in a much larger data set with a lot more columns, there's a lot of choices that XGBoost can take into account, and it can split on, whatever columns it wants. It can split wherever it wants. And so it gives a lot of chances for these trees to fill in each other's mistakes and make better predictions. Okay, so now we've talked about how decision trees and XGBoost works overall. And so now we can dive into some of the details of our specific implementation. One key point about, or one key difference about our implementation is that XGBoost and Vertica, just like our random forest algorithm, supports categorical columns natively with no pre-processing. So categorical columns are very popular in tabular data sets. We just saw an example, which was the make of the car, Toyota and Lexus in that case, but you can imagine columns with more categories, or different categories. It can be colors, it can be pretty much anything else. But the key point about categorical columns is that they're not as simple to deal with because they're not simply numerical values, which can be compared however you want. And so many other implementations of XGBoost require these categorical columns to be either one-hot encoded or mapped to integers. And there's some problems with these approaches. One-hot encoding takes up as many extra columns as there are categories in that column. So it transforms one column with categories into a bunch of columns. And for obvious reasons, that's often not what you want. Maybe you already have a lot of columns and you don't want to run out of space or add more columns, etc. And so one-hot encoding is not the best option in this case. And mapping to integers is also not a great option because then the algorithm treats these values as if they were numerical values. So for example, if we mapped Toyota to 1 and Lexus to 2, it would make the model treat Lexus as if it was a greater value than Toyota, which doesn't really make sense and might work okay, but it's not a great approach. Instead, what Vertica does is we under the hood have a whole separate way that we handle these categorical columns, and we treat them as distinct categories and split on if a category is a certain class or category, rather than doing one of these other approaches. And the other key point is that this all happens under the hood, if you will, and without any input from the user. So you don't have to pre-process your data. If you have a bunch of categorical columns, you just fire up Vertica and run your XGBoost function. Yeah, so here's just a little quick comparison with our XGBoost versus Python. And this is definitely not exhaustive, but this is just a quick test I ran on a popular data set. The data set is the all-state claims data set. Its task is to predict how much a certain claim cost Allstate as a company. Yeah, and you can follow this link to learn more about this data set, but it has a bunch of columns. It doesn't have a lot of rows, but it's a pretty popular data set for testing in the machine learning community. And so I ran all these tests on a single node. Obviously, Vertica is not really meant to run on a single node, but even so, Vertica performed better with quicker runtime and a lower MSE. MSE is mean squared error, so we want less error, so lower is better. Yeah, so that's just a quick example. Yeah, and so some details about that example. The data set there was very small. Vertica, and part of the reason for that is that Python can only handle as much data as you have memory. And while there are pretty huge machines nowadays, it's still usually very expensive if you want like gigabytes, or I guess more than a few gigabytes of memory. But Vertica doesn't have this limitation. And so Vertica can handle terabytes and even petabytes of data kind of without missing a beat on commodity hardware, as you all probably already know. Yeah, Python is limited to the single machine it runs on. Yeah, and even more so than just the memory, Vertica can also scale to tens or even hundreds of nodes. And since XGBoost is in Vertica implemented as a distributed algorithm, it can scale with bigger data as long as you have enough nodes to distribute it on. So at a certain point, Python will kind of just not be able to handle your data because you probably just won't be able to load it. And then you're kind of out of luck. But with Vertica, you don't have this limitation because you can always add a little, like another node if you need more processing power. Okay, so now let's go over a Vertica specific example. So say you want to train and predict on some data in Vertica, and you can do this on any of your Vertica tables. In this example, we're going to use default parameters, 10 total trees trained. So these trees are the decision trees we talked about earlier, and each tree has a depth of 6. Again, we're using the all-state data set, predicting cost of claims based on the predictor columns. And so the steps are pretty simple. So first, I'm just going to show you, how to train and how to predict. So this first function call, just a simple SQL call. It selects XGB underscore regressor, and then you provide the name of your model, the table that contains all of your data, the column that you want to predict on, and the columns that you want to predict with. So the predictor feature columns. In this case, we just give a star. And then we exclude a couple columns from that star so that the ID column is not predicted on because it's not relevant. Okay, and so that runs, and finishes. And then once you have a model, you can predict on it by doing predict underscore XGB regressor. And you provide the columns to predict on, you provide the model name and the table to predict on. In this case, I'm just predicting on the same table that I trained on, but of course, in a real world scenario, you'd probably be predicting on some new data. Yeah, and so here's an example, the first 3 values of the prediction, just some costs. And yeah, the important point is that you can, as with all of our algorithms, you can make a bunch of models, call them, a bunch of different names, provide different parameters, experiment maybe even with different data, different subsets of data, different depths of trees, different numbers of trees, and then compare all them by predicting on some, let's say, test data set. And so that's actually what we're going to talk about right now. So here's, a little more, I guess, in-depth example. So, let's say you have a model or models and you predicted on it, that's great. But you also probably want to know, how good is your model? Is it actually making good predictions, or maybe do you need better data, or do you need to update your parameters? So in this case, the first function call here is, and we create a new table. Here I've called it XGB preds, so XGB predictors, or yeah, predictions. And into it, we put the loss column from the data set as the observed or the ground truth values. And we predict from our model and store that as a predicted column into our XGB preds table. And then we select the MSE. Again, the MSE is just the mean squared error of the observed, between the observed and predicted values. And we get this MSE. And in this case, this doesn't really mean much by itself, but you can imagine having a bunch of models and predicting the MSE for each one of them, and then you can see which ones perform better or worse. And you can compare this with other XGBoost models, but you can also run random forest or one of our other regression algorithms and predict it with that and see if maybe a different algorithm is best for your specific data set, or if XGBoost does outperform the others. Yeah, and so a pretty exciting fairly new thing is we have Vertica Pi now, and there's going to be another, or maybe has been another presentation on it already. And so XGBoost is one of the things that can be used in Vertica Pi. So the Python comparison earlier, you can use what Python has always had over Vertica is if you're used to it, it's a very easy thing. It's a very easy language to work in. But with Vertica Pi, there's no longer that switch that you have to do. So you can take all the power of Vertica and use it in your Jupyter notebook or what have you, and have it be just as easy to use. So in this case, this is using the XGBoost classifier. So in the previous slide, I had an example with the XGBoost regressor. The XGBoost classifier works in the same way. It just predicts classes or categories instead of values. Yeah, and so this isn't an end-to-end example, but this gives a good idea of how this would be used in Vertica Pi. You import XGBoost classifier from Vertica Pi. You make your model. You give it the table, number of trees, max depth. These are pretty high values. Likely on a good data set, you wouldn't need such high values. And then you display your model, and here we also see all the parameters that you can tweak if you would like. So some extras. Yeah, as I mentioned, classification works the same way. In Vertica, you just have XGBoost underscore classifier instead of regressor, and prediction is analogous. Yeah, and so another key point, Wakas earlier was talking about how XGBoost is explainable, whereas neural networks are not. And this is how you would explain your model. So let's say you have your model and you want to see what exactly is going on in there. What did it learn from your data? And so you can run this read tree function, and you can either provide it a tree ID or omit the tree ID parameter completely, in which case it would output all the trees in the model. And so you get this somewhat legible output. But if you take that output and copy it and put it into a Graphviz visualizer, then you get this kind of graphic. And this is just a small part of the tree. But you can see the little names on the right, cont7 and cat113, are column names that you passed into the model. And we can see that here it's splitting on, for this top bubble, it's splitting on 0.62, then it's splitting on 0.32, etc. And at the bottom in red, we can see the predictions and how this specific tree, if a certain row went down to any of these specific predictions, how it would affect the overall prediction. And so this is a really powerful tool because, if you want to, you can take a data point and follow its journey all through your trees and see exactly where it went and what happened, and maybe if there was an error or an unexpected output, you can see, oh, like that happened because the model split on this specific column at this point, and maybe if I provide more data to that, some more different examples, it might split a different way and then give me either a better or different result. Yeah, and so as usual, there's the analogous function in Vertica Pi, and you get the same thing, but in fact, you don't even have to copy and paste it into some site. You just import Graphviz and output your image. Yeah, and here's just a list of the optional parameters for XGBoost. We have, I'm not going to go through all of these. I'm just going to go through a couple key ones. We have max n tree, which is the number of trees that XGBoost will train in the model. We have the max depth, which is the depth of each tree. We have the learning rate, which affects how aggressively each tree is trained and how much it tries to fill in the mistakes of the previous trees. We have, and then we have some of the sampling parameters, sampling size, which samples by row. So you can select a ratio of how many rows of the data set you want each tree to be trained with. And we have the call sample parameters, which stands for column sample subsampling. And this affects what percentage or what fraction of columns will be used to train each tree in each node. And so these sampling parameters can be used to, maybe if your data is very big or you have a lot of columns, they can really, first of all, speed up your training. And second of all, they might actually give you better results because your model might learn a little better in the absence of all the information than it would when given the training data set completely to memorize. Okay, so in summary, Vertica now offers XGBoost for classification and regression. And the key points are that XGBoost is fast because it trains a bunch of simple models. It is very scalable, mostly because Vertica is very scalable. It is explainable, as we saw with the read tree example. And perhaps most importantly, it is in the same place as your data already is. So unlike external libraries, you don't have to export your data and then train it and then import it and export new data to predict on or anything like that. Everything is all in the same place. So you take your data, you train XGBoost, you predict on new data, and yeah. So that's the end of my presentation. Over to you, Joy.
Thank you for listening to this presentation. Now we're ready for Q&A. Okay, and so I do want to thank both George and Waqas. George is not able to join us for the Q&A, but I promise you that Waqas will be able to answer a lot of your questions, if not all of them. And then the Developers Lounge, as we've mentioned throughout the day, begins at the top of the hour, and you'll be able to stop into the Machine Learning Developers Lounge room and continue the conversation, whatever you like. So we actually do have several questions that are coming in, no surprise. And we have the top vote is, if I want to train my XGBoost model in Vertica and then apply it multiple times on new data, how can I do that?
So yeah, if I understand that question correctly, it has two parts to it. One is the prediction. So if you want to predict on it, how do you do that? The second is maybe I'm sensing a thing like automating that process. So I'll answer those two parts separately.
Okay.
So the first part, if you see Vertica's API for SQL for Python, in both cases you have training algorithms plus you have prediction algorithms along with evaluation and other functions that you get. So in the case of XGBoost specifically, as George showed in the presentation, we have the XGB regressor. So you do a select XGB regressor, and you can train a model with that. But once you have saved a model in Vertica by training it, then you can use it to predict on any new incoming data. So let's say you wanted to do that manually. You could write in SQL the script predict XGB classifier or regressor, whichever one you're using, and then tell it the name of the table on which you want to make the prediction and the name of the model and things like that. So that's the standard format that you will find in the documentation. But here comes the interesting part. If you want to run it and make it automated, for that, again, diving down and dividing it into two parts again. One part is around the data that's incoming, and you want to perform some operations on that because most of the data that is input into the database, it needs to go through data transformation and data preparation. So there is pipelines that we now support with the Vertica Pi. You can use those pipelines that any new incoming data should go through normalization, missing value imputation, and things like that. You can write functions for that. And once that is done, then apply this prediction function of XGBoost. So that is something you can do today. If you want to automate it further, it should keep on reading from a certain table, that whenever some new data becomes available in this table, then trigger this pipeline or the predict algorithm in case the data is already prepared. You can write scripts for that. A lot of our customers are actually using Airflow and writing their scripts and triggers in that. But we are working on automating that in Vertica as well. You might have heard in one of the other talks that we are coming out with some new features in which the roadmap includes supporting triggers, as well as these sequential commands where you'd be able to write a stored procedure, which would, again, this is part of the roadmap right now, but you would be able to automate that all through Vertica by writing these stored procedures that would get triggered at certain data updates or table updates and things like that. So a long answer, but hopefully I captured the you know,
Well, it
the
was a
essence of the
two-part
question.
question. Right, so
Yeah.
that counts as two questions that you answered, so no apologies necessary. Now, you did mention, and it was mentioned in the session as well, Wakas, about XGBoost being highly scalable. But a question has come in that says, well, when you say it's highly scalable, what's the maximum data size that it can handle? Is that really even an XGBoost limitation or a platform limitation?
Yeah, I think that's a good question because whenever we think about any data set or any algorithm, especially most of the data scientists, they actually start from R or Python or some of them in school through SPSS. So when it's, I would say, intuition that whenever you think about any new problem, you're looking at the amount of data that your tool can handle. And that's the exact mentality that we suffer from until we hit some big data, and then we're thinking about sampling, how we can reduce the amount of data and then apply that algorithm. And that is exactly what we are trying to solve through Vertica, that you should be thinking about your use case, you should be thinking about the value you can get out of a certain algorithm or these functions, not constrained by the amount of data it can handle. And that whole concept applies to this XGBoost algorithm. XGBoost in general, even without Vertica, is considered an algorithm that can scale pretty well and can give you pretty good results on structured data. If you look at Kaggle competitions, as we mentioned in the presentation, they are winning a lot of structured data competitions. And part of that reason is they can handle big data. But once you bring it to Vertica, like we have done now, we are taking it to a whole another, different level. Now you can break free, I would say, literally from any data size restrictions. Now, answering it in exact terms of this many terabytes or petabytes, that would be difficult. There's a lot of components on which it depends. Your the size of the cluster that you have, the resources you have there, memory, CPU, power, and things like that. But essentially, if I had to answer it really simply, it would be if you can fit a data set in Vertica, you can apply XGBoost algorithm for training and prediction on that data set.
So that's an excellent answer, and it will bring me to a question later about the opportunity to replicate or really prove out a model. But for now, I want to pivot to another question that I think you've convinced some people in the audience that this really is an opportunity. What the question says is, the part around storing models in Vertica does sound really interesting, but we already have some models that we built in Python. So how can we store the same models in Vertica that we built in Python?
That's a great question. So from Python, you can actually bring your models into Vertica. There's multiple methods that we support today. If we talk about the roadmap, again, PMML is a very exciting field that we are exploring. So from those models, you can convert all your models from Python into PMML and then bring them into Vertica. So right now, the models that are supported are linear regression, logistic regression, and k-means clustering, including lasso regression, ridge regression, elastic net regression. So all of those are also supported. The plan in the next release is to work on decision tree-based models, including random forest and XGBoost. That's coming soon. But if you wanted to bring it through Python, Vertica Pi would probably be the route that I'll point you towards. That is something you can use today to bring your models into Vertica. And same goes for exporting models as well. And again, it's always a discussion of the model size. Like hosting is always a good thing for model management in Vertica, but a lot of times you'd be surprised by the model accuracy that you get just by training your model on larger data set. So even worst case scenario, let's say you have to train that model in Vertica, it would be worth it.
I would find it hard to argue that training a model on a larger data set wouldn't contribute to accuracy. That seems like a fairly logical expectation from what I could see. So yeah, I think that's very important. And these days, accuracy is pretty important. So
yep, it is.
Now here's one. They're testing me to see if I know how to say this properly. Does Vertica treat varchar or is it varchar columns as category? Variable
Yes,
character.
we
I
do.
do know what it stands for.
Yeah, so in Vertica, we have varchar and long varchar. These are how we define categorical columns. And I think, again, the context of that, if I have to assume, is that a lot of other tools in their XGBoost implementation, they do not support categorical columns. Vertica does. And yes, varchar is the way to store those categorical columns.
Okay, and varchar is also the way to say it. So now another good takeaway for me. Now, does Vertica support any other tree-based models beyond XGBoost?
Yeah, as I mentioned, so XGBoost is not exactly the culmination, but it's the peak point in our journey that we started around decision trees. So we have already built random forest models into Vertica, and the way Vertica designs these algorithms and put APIs on top is we don't want to create a lot of clutter. So sometimes you'll find a lot of algorithms clubbed into one. So random forest also is decision trees. If you set the number of trees to 1, that's a decision tree that you get. You can apply it for regression, the random forest regressor. You can also apply it for classification, the random forest classifier. And then we have the XGBoost. Both regression and classification are supported for XGBoost. So these are all decision tree based. If I have to count, you start from simple decision trees to random forest and now XGBoost. The plan is to go forward, keep on building more decision tree based algorithms. So CatBoost and EdaBoost are two of the algorithms that we're thinking about right now. But if there's anything, any of our customers think should be prioritized before another, you want EdaBoost before CatBoost, or maybe some other boosting algorithm that you're using in your environment, let us know. We'd love to hear from our customers and prioritize our roadmap accordingly.
Okay, so Waqas, another question that I think is very relevant here is there's a lot of talk about being able to prove the accuracy of these models, especially complex models, especially ones like you referenced about credit scores or about malicious actors or any number of different examples of this. What is it about the in-database machine learning and the capabilities in Vertica that give enterprises the opportunity to be transparent, to prove out how their model was, how the outcome happened? Because we've heard a lot of stories about companies that say there wasn't a bias, there wasn't a mistake, but they struggle to prove it.
Yeah, so that's, I would say, one of the strong areas of Vertica, and we handle it in two ways. One, as we talked about earlier, is by handling all of the data that you have available. What that gives you is usually a more accurate model. By usually, I would say in most of the cases, higher the amount of data that you have, and quality data, not just any data. The higher the quality data that you have that you can input into training of an algorithm, the better the accuracy of that model would be. Or if there's any metrics like precision or recall that you're aiming for, more data usually results in better metrics. So that's part one. But for a lot of organizations and the customers that we work with, what happens is that once you've trained a model, you've put it in production and it's making some predictions for you. Let's say it was the case of that credit card classification, approval, or disapproving an application case. So what happens is that after some time, you have to take that model out of production and put another model into production. Now, storing these models, all the serialization, deserialization, that's tricky. And let's say there is a bank that is a customer of Vertica that has a new model every week that they update. So if they have to look at a model that applied a certain decision 1 year from now, 52 weeks back, so they have to go and load that model again to look into that. In Vertica's case, all the models are stored in Vertica. It's a storage layer, so you don't have to worry about serialization, deserialization. All the models are searchable as well. So if you want to look at a model that you created and that helped you make a decision 52 weeks back, you just type in the model name or find the date range, and you can just look at the model and exactly show that this was the model. This is stored here. It would be a very small footprint in the disk, and you can exactly answer those questions with the read tree method on that model.
Well, that's an excellent answer, and honestly, I think that that as we evolve into a society that depends more and more on machine learning, building trust in outcomes is critical, and being able to prove how something happened transparently is how you build trust. So thank you very much for that, Waqas. This is a really good session. Now, as I mentioned, anybody that has more questions, and I have to admit there are more questions pouring in, not unexpected, please do drop into the Developers Lounge, which begins in about 11 minutes, hence why I want to make sure we end on time. And also, if you listen to this morning's keynote, you know how important it is to enter the code into the Analyze to Win platform to earn points, earn prizes, and contribute to making a difference in a dog's life. And the code for this session, and spelling is very important, is St. Bernard. In this case, it's ST, period, Bernard. So type in St. Bernard to the Analyze to Win platform, earn the points, and then go visit experts like Wakas and others in the Developers Lounge in just about 10 minutes time. Thank you very much, Wakas. It was really fun as always.